Hello, and welcome back to Mammalian Anatomy at Keuka College. Today what we're going to do is we're going to focus on the cerebellum. This will be a continuation of our lecture on Chapter 13, the central nervous system. So where is the cerebellum? And essentially we're going to study its anatomy and what does it do. So let's talk about the cerebellum. So the cerebellum is actually going to be the second largest portion of the brain, and it's actually going to be dorsal to the pons. So it's going to be a little bit more posterior over here. It is a highly folded structure, and so we can see the folds are actually going to be much tighter than they are in the cerebrum. So let's talk about the anatomy of the cerebellum. So the cerebellum is going to actually have two cerebellar hemispheres. It's going to be on one side and another side. And the hemispheres are actually going to be connected by a vermis. So a vermis means worm in Latin. And so it's going to be a worm-like connection that is going to go along the center of the cerebellum. We can see that the cerebellum is highly folded. We call these folds folia. And as we'll see, folia actually means leaves. When we go into the internal structure of the cerebellum, so here we have a sagittal cross-section of the cerebellum, we can see that there are regions of gray matter and white matter. The white matter creates this beautiful structure that is branching like a tree. And this branching white matter is called the arbor vitae, the tree of life. So, which is super cool, and I think it's beautiful, and it's my favorite structure of the brain. And around the arbor vitae, the tree of life, we have gray matter that are going to fold over the white matter, and we call these folia. The folia means like foliage or leaves of the tree. So it's Latin can be kind of beautiful sometimes that way. There are going to be deep fissures that are going to divide the folia of the cerebellum, and the cerebellum is going to be divided into lobes. There's going to be an anterior lobe, a posterior lobe, and a very, very tiny, I can't actually, I always get tongue-tied with this word, folliculonodular lobe. If you can say it, record it and send it my way. I've never been able to get it quite nicely, but we have the anterior lobe and the posterior lobe and this alphabet soup of a lobe. All right, and deep within the folia, we're going to have the deep cerebellar nuclei. Okay, so that's the anatomy of the cerebellum. To the functions of the cerebellum. The cerebellum's major function is to actually coordinate the movements of the trunk and the limbs. It is important to know that the cerebellum doesn't initiate these motions. Rather, these motions are going to be initiated in the cerebrum, specifically in the primary motor centers. However, the primary motor centers create very jerky and kind of coarse motions. And so what the cerebellum is going to do is it's going to smooth out these motions by integrating information from proprioceptors, photoreceptors, and equilibrium receptors. And the cerebellum is going to be able to adjust these motions to make them very smooth and clean. Also, it's going to help adjust our posture so that we are able to maintain equilibrium. So we're able to sit upright and we are able to stand upright without kind of falling over. It also coordinates head and eye movements. It will work along with the midbrain to be able to create those auditory and visual reflexes that we talked about in our previous video. And the last thing that I think is really cool is motor memory. So whenever we talk about like muscle memory, the cerebellum is going to be responsible for that. So it's going to allow us to be able to have habits like riding a bike or driving a car. Once we learn how to do those actions, our cerebellum can kind of take over and we can do them somewhat subconsciously without having to focus on each individual portion, like how to turn the wheel and like where to put our foot on the brake and the accelerator, those sorts of things. Okay. So let's talk about how the cerebellum actually integrates various sensory information to allow for our voluntary motion to be smoothed out. This diagram isn't in your textbook, but I think it shows a really good way of how this information is integrated. So we're going to kind of divide this into 3 parts. The first part is that the cerebellum is going to receive information from the cerebrum about the planned movement. So the primary motor cortex of the cerebrum is going to initiate the motion, and it's going to say to the cerebellum, hey, this is specifically what I want to do, and let's figure it out. So the primary motor cortex is going to initiate the plan, and then what it's going to do is it's going to send this information first to the pons, specifically the pontine nuclei, and the pons is going to relay this information to the cerebellum, specifically the anterior and posterior lobes of the cerebellum. So the motion is initiated in the cerebrum. It's going to go to the pons and then be sent over to the cerebellum. The next part is the cerebellum is going to kind of compare this planned movement to the body's current position and movements. So the cerebellum is actually going to take in this planned motion that the cerebrum wants the body to do, but it's also going to take information in from our vision, from the equilibrium in our ears, so where our body is in space and time, how we're accelerating, how our head is turned. And it's going to receive information from our proprioceptors. Proprioceptors are going to be located in muscles and joints and tendons. And what proprioceptors detect is where our body is in space and time. So you may be sitting at your desk or sitting in bed, and you may know exactly where your ankle is and what angle that ankle is located in or positioned in. And you don't even have to look at it. You know, using your proprioceptors, where that ankle is located. So the cerebellum is going to take all of this information, visual, proprioception, equilibrium, and integrate that with the planned body movement and figure out like how does that planned body movement fit in to where the body is at the current moment. Then what's going to happen is the cerebellum is going to send this information back to the cerebrum, and it's going to say, hey, this is where our body is right now. This is the planned motion that you would like to do, and this is what you have to do to kind of correct or make any adjustments to those motions. Eventually, this information is going to go back to the cerebellum and then go into the motor neurons, and then continue that motion. So it's going to help with that fine tuning of these motions of our body. This diagram is going to kind of illustrate that here. So we're going to see that motor information is going to go from the primary motor cortex to the pons, then to the cerebellum. The cerebellum is going to process all of this information, the kind of motor efferent copy, so what is the planned motion, proprioception, somatosensory information, visual information, and vestibular information, what is our equilibrium information coming from our ears, and it'll send that information back to the primary motor area so that the cerebrum can actually make adjustments. And then from there, our body will move. So it'll help kind of coordinate those motions. Individuals that have a stroke in the cerebellum may have more jerky motions and also have a different gait when they walk. So it'll affect how their body moves. Thank you for listening to this video on the cerebellum. I hope you have a wonderful day and be good to yourself. I'll see you in the next video. Bye-bye.